Hey folks, in this video we're going to start addressing our second concern. Our issue there was what happens if I push and the thing's already full. Okay, so you can imagine this case, right? We have an array of of only size 4, right? And the stack is of size 4 as well, right? I have n equal to 4. Looks like this, right? What happens if we push? Well, we already talked about this a little bit, but there's going to be an exception, right? There's going to be an exception saying array out of bounds. Because when we go to do that push function, push basically going to look at the index n is 4. Well, this array only has indices from 0 to 3. 4 is out of bounds. So we'll get a nice exception. Everything will crash and burn, right? Obviously, we can't let this go, right? We got to fix this somehow. So what can we do? Easiest thing, make it bigger. Make it one space bigger. Then that'll be enough, right? One space bigger, it'll be enough. So here I have basically done that, right? You can see I've gone to push on the element 10, and now we have 5 spaces in there. Life is good, right? And so we could always think about doing that, is making it one bigger each time. Does that seem okay, or is there maybe a problem with that? So that does work, but it's a little bit odd, because we're having to do the work every time we add something, right? So every time I add an element, I got to resize. And what we'll figure out, and we'll see later, we'll talk about a little bit, is basically this idea of whenever I want to resize an array, that means I have to create an entirely new array and copy everything from the first array to the second array. Okay, this is bad, right? This will cost me time because I need to go and touch every single element in there. Right? I need to move every single thing over from the old place to the new place. That's going to be a lot of work. Right? So it would be better, right, that if I maybe made it, more than just one bigger. Maybe I make it 10 bigger, or I double it, or something like that. Or if I have a rule that makes it bigger when I add elements, I don't have to do it as frequently, right? Or what I want to do is I want to avoid having to resize the array frequently. I want to grow when I do resize it. I want to do it more frequently, and I want to do it for a larger increment, right? I want to make more space, right? That'll be more advantageous to me in terms of a performance. So that's what we'll aim to do. So here's our code. Take a minute, think about it, and then we'll talk. Okay, so first question for you guys here. Does this look good? Hopefully it does. This is, is pretty good. There's only one little thing here, right? What happens if n is equal to 0? Excuse me, if cap is equal to 0, what happens then? Okay, so this looks pretty good. Let's take a look at the code and then look at the questions over here. So in the code, let's try to highlight what's changed. So the primary change is over here. We've added a new method, and we've added a way to call the new method. Those are our 2 big changes. So let's take a look at push. In push, basically what we're saying is, are we full, right? If the size of my array is equal to basically, well, if the number of elements in my array is equal to n, what that says is, oh, it's full, right? Remember that n both means the number of elements in the array as well as what is the next space to put it. Well, if the length of the array is equal to n, that implies the number of spaces, the number of elements are the same, so we got to expand it somehow, right? So we got to call resize. That's our first change. So resize over here uses a function from arrays, right, which is a Java library. So we basically go and call copy of, right? So copy of goes to the array, right? So initially I have maybe an array, right? It has these elements in there, A, B, C, right? And I go call copy of, and it makes me a new bigger array, right? And so it's some fraction bigger, right? And it'll basically copy over A, B, C. And that'll be a little bit of expense because you have to go look at every element. In terms of big O, this is going to be big O of n, because there's n elements in there. I got to copy n elements from the old one to the new one. That's what I said before. It's a little bit of expensive operation. It's something that we want to avoid if we can. Okay, so we make that copy. And so in here, right, basically what we're doing is we're saying make a copy from the data array and basically save it into data, right? Make a new array and save it in that variable. And the size of the new variable, a new array, is going to be twice the old one. Okay, so that's our rule there, right? We don't want to make it just one bigger. We're going to double it, and that'll be a pretty good rule in practice. All right, so that's our implementation there. That's how it works. This looks pretty good, but there's that one question there. What happens if cap is equal to 0? What happens? Well, there's a problem, right? This is a doubling operation. If your initial array is 0, well, then this is going to be 0 times 2. It'll never grow, okay? So we probably would want to add in here, right? Another adjustment, I won't do it here, but we could basically make sure that cap, is greater than 0 would be some sort of requirement to add. All right, so let's see. So this looks pretty good. Probably this is the one thing we have to care about there, right? Or maybe we can fix it some other way. So yeah, so let's look at it. So this is saying, how do we look at the constructor? How do we look at the pop? So the constructor is pretty good. One thing we could maybe do is add something like a default constructor. That might be a good idea. The other thing we can do is look at pop. We still have a concern where pop could throw an exception. So that would be another issue. All right, but all in all, this looks pretty good. In the next video, we will fix that those next pair of problems. So we'll take a look at the constructor, we'll take a look at pop, we'll fix that, and it'll give us kind of a very good stack implementation.